a rare celestial visitor has captivated astronomers worldwide. 3I/Atlas, an interstellar comet that entered our solar system this summer, is offering a once-in-a-lifetime opportunity to study material from beyond our solar system. Researchers say the comet is particularly intriguing because nickel vapor was detected in its surrounding gas, a finding unusual at such a cold distance from the Sun. The comet is special both because it is interstellar, meaning it came from outside our solar system, and also because nickel vapor was detected in the gas surrounding the comet. This comet, called 3I/Atlas, is only the third such interstellar object to enter our solar system in recorded history. Observing such a rare occurrence is extremely valuable for us because it's the only opportunity to look at this object before it moves out of our solar system, said Daryl Z. Seligman. Seligman is an assistant professor of physics and astronomy at Michigan State University who is coordinating international teams of scientists that are observing 3I/Atlas. Rohan Rahat-Gunker, a PhD student at the Institute Astrofísica Pontificia Universidad Católica de Chile, and Thomas Puzia, who led the team there that made the discovery, were among the authors of a new research paper describing the nickel vapor detection. The findings are notable because the nickel gas surrounding 3I/Atlas was detected at a huge distance from the Sun, nearly 4 times Earth's distance from the Sun, where temperatures are too cold for metals to normally vaporize, Rahat-Gunker told NPR in an interview. Puzia said of the data, "It was pretty clear that it was nickel, so it was super exciting." Puzia cautions that there's still a lot of evidence collection and research to be done into what these findings could mean. But this study into 3I/Atlas opens the door for new insights into the chemistry of objects and materials that originate far outside of our solar system and are likely billions of years old. He said the comet could be older than our solar system. 3I/Atlas was first confirmed on July 1 to be the third interstellar object known to have come into our solar system in a sky survey by the Asteroid Terrestrial Impact Last Alert System, ATLAS. When Rahat-Gunker and another student, Baltasar Luck, were set to observe the comet through the Southern Astrophysical Research or SOAR telescope in Chile, they were not looking for nickel vapors. But over multiple days of observations with the Very Large Telescope in Chile, and as 3I/Atlas continued its journey closer to the Sun, Rahat-Gunker and other researchers found that levels of nickel vapor continued to increase. They measured the nickel using a host of instruments including a spectrograph and by looking at characteristics of the light coming off the comet. Rahat-Gunker and Puzia also credit a team of researchers around the world using telescopes and other instruments for helping to observe and analyze data on the comet. Journeying at a rare high speed for a comet, around 37 miles (60 kilometers) per second or 133,000 miles per hour, from the direction of the center of the Milky Way galaxy, 3I/Atlas is currently on the far side of the Sun relative to Earth. The only other such interstellar visitors previously observed by astronomers were objects called 1I/Oumuamua, detected in 2017, and 2I/Borisov, discovered in 2019. Harvard University astrophysicist Avi Loeb told Reuters that observations in the Mars flyby confirmed earlier data indicating 3I/Atlas is far larger and more massive than the previous interstellar objects and most comets. Over the past 5 months, there were more than 4,000 data points collected by 227 observatories around the world of the motion of 3I/Atlas through the solar system. And in collaboration with 2 colleagues, we used all of that data to infer that there was no deviation of the trajectory of Atlas from a path sculpted by gravity alone. In other words, the object is extremely massive, and it doesn't really care about the mass loss in terms of the orbit that it shows on the sky. We concluded that the mass is larger than 33 billion tons, meaning that at solid density, the object's diameter is bigger than 5 kilometers, comparable to the size of Manhattan Island. Moreover, the timing of its arrival is such that it comes very close to Mars and Jupiter, and that is good news. It's a gift from interstellar space in the sense that we can observe it with all the orbiters that we have around Mars and Jupiter. And its big size allows us to see it even with relatively small aperture cameras. In fact, on October 3, 3I/Atlas came within 29 million kilometers from Mars, and the European Space Agency released images from the ExoMars orbiter. They seem to confirm what we already saw in the Hubble Space Telescope image, that most of the gas surrounding 3I/Atlas is carbon dioxide, 87% by mass, there is 9% by mass that is carbon monoxide, and then only 4% is water. Moreover, observations from ground-based telescopes indicate that there is nickel but very little iron in the gas plume around the object. Usually we see comparable amounts of nickel and iron in comets. The only place where we see much more nickel than iron is in the industrial production of nickel alloys. And so that raises an interesting question of what is the pathway that led to us seeing mostly nickel and not much iron around this object. The best is yet to come. There was data taken on October 2nd by the HiRISE camera on board the Mars Reconnaissance Orbiter that NASA put around Mars. That camera reaches a resolution of 30 kilometers at the distance that 3I/Atlas was from Mars on October 2nd. Because of the government shutdown, this data was not disseminated to the public and to scientists, and that is rather unfortunate. I was asked whether that may be some kind of a conspiracy, that there is perhaps a reason for that which has to do with extraterrestrial intelligence, and my reply was that it's much more likely to be the result of terrestrial stupidity than extraterrestrial intelligence. So 3I/Atlas, if it continues along its current path, will definitely leave the solar system with a relatively modest deflection relative to its original direction of motion. Then it will move on to the next star along its path. And if it has been doing that for on the order of 10 billion years, it must have passed close to many stars before. So, it's a well-experienced interstellar visitor that went through many backyards before it entered ours.